My name's Brendan. I look after marketing for Ixia in Asia Pacific. Ixia is probably one of those biggest little companies you've never heard of. Who's heard of Ixia in the audience before? Ah, Susan in the back. Okay, thank you. So I'll start with a bit of an introduction as to who we are and what we do in the industry in general. And then I'm just going to quickly get into what the relevance is, particularly to CA and similar types of technologies. So, Ixia network visibility architecture is what I'm going to talk about. I'm not just going to talk about CA spectrum. That's just a use case I'm going to go through. Boy, that noise on the back is actually hard work. Yeah. So, Ixia as a company, we are the company that we like to brand as the company in networking. The biggest names in networking trust Ixia to help them with their products. And we have multiple segments of our business, which I'll just take you through very, very briefly. So we are a test and instrumentation company and a network visibility company. So we do test and measurement in pre-production networks and post-production networks. And we go through the whole life cycle from the test and development of chips, the Wi-Fi chips, processing chips, right through to in-life visibility of operational networks and tools. So briefly, our test business, we develop and manufacture test products for chip manufacturers, for equipment manufacturers, Cisco, Juniper, these types of companies, but also security vendors, such as Fortinet, such as Palo Alto, such as Cisco. Also for lots of other application intrusion detection vendors. So we sell test equipment to all of the actual network equipment vendors, be they pure networking, switching and routing, security, firewalls, next generation firewalls, web firewalls, all of application delivery controllers. We sell test equipment to all those vendors in their test and development of their products. So their development and the test across security. We sell these test and measurement equipments to service providers and telcos. This is primarily how telcos and service providers test the equipment they're going to deploy for vendor selection, for operational considerations, for designing the network, the scale for wireless networks, LTE. We sell to Wi-Fi vendors as well. The last most important customer segment we sell to is enterprises. And what we sell here is, A, some security test equipment, but more importantly, what I'm going to talk about today is what we loosely call network visibility solutions, enabling network visibility of how the applications are running on your network. So that's what I want to focus on today. I'm not going to obviously take you through all those products. What we're going to talk about today is one key aspect of our business, which is enabling visibility of applications and network traffic on the network. How did we get here? If you look at how did we get to the problem of network visibility? Well, as we all know, and many of us have lived through these transformations, we started in the early 90s with internet taking over, IP networks taking over, VPN networks taking over, and the problem then was very much defined by just connectivity, building out branch networks, building out IP connectivity. The number of applications would be inherently limited. It would be an email application generally. It would be a CRM application. And it was just about connectivity at that point. That was the internet transforms the communications. That was the first step. Where we went next is, hey, that was pretty good. We've got big networks. We're actually delivering email remotely to all our customers in our branch offices and all our clients. We're delivering CRM apps. We're delivering these things. That's pretty good. So that just started to explode. It took off at that point. We got a lot more applications on the network. So we went very quickly in a few short years from 4 applications on the network to probably 10 or 20. Then we got smartphones and tablets and consumerization of IT. And now it's gone completely nuts. So, the phone is a classic example, right? When we had BlackBerries only 5 to 10 years ago, we had one application. It was an email application and calendaring application off your Exchange server or your Lotus Notes. Now we have a smartphone running 40 applications, 50 applications, right? That's just one example of it. I'm banging my microphone as I go through this. So, consumerization of IT is a term we've all heard, but what's the impact as the applications meet the network? And the impact is multi, right? We have a huge number of security implications in the network. With all these different applications, with all these proliferation of devices, we have security implications. We have many more intrusion detection systems. We have many more new web firewalls. We have many more new next generation firewalls. We have all sorts of critical applications now running on the business. Now, why is this important in the application and the networking space? Because that has very quickly led to the development of the tools market. So as soon as we started putting this many applications on the network, as soon as we had more than just a few applications we were trying to keep track of, then we started getting a lot of tools. Tools to look at what's going on from a security perspective. Tools to look at what's going on from a specific application performance perspective across my network. Tools to look at security and compliance, compliance call recording. Tools for any different things, application performance monitoring tool related to a specific SAP or a CRM application. Tools related to the delivery, monitoring the delivery of applications into a particular site or only for particular applications. Tools for monitoring trades in investment banks. Tools for keeping track, monitoring the delivery of ATM transactions in financial networks. Tools, 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 tools. And that's what consumerization of IT has done as the applications meet the network. That's created a problem of visibility in the network. What's going on with my applications on the network? This is where the applications people meet the network people, tell me what my applications are doing on my network. That's what we call the visibility. Okay? So let's just draw this quickly. So, on the left side of the chart, what have we got? We've got all the places out there. We've got the big branch offices and the campuses. We've got the remote branch offices. We've got people VPN dialed in. We've got people with just SSL connections running apps into cloud services off iPads and phones and stuff. We've got core data centers, either privately in your own operations or actually outsourced cloud services. Okay? You've got virtualization going on. That's creating even a bigger visibility problem. Okay? And you're all doing this globally. Over on the right side of the network, you've got network management tools. You've got application performance tools. You've got security intelligence. From just in the financial services industry, right? There's all sorts of compliance around understanding what's going on in your network. And you've got customer experience. Customer experience loosely meaning call quality, loosely meaning exchange turnaround times, loosely meaning like SAP transaction performance times, things like that. So here's the tools. Here's the laundry list of tools that comes out of this, right? And there's lots of tools out there now. Okay? The key challenge now, and the visibility challenge, is connecting all those tools to all those networking places out there on the left of the chart. Right? How do you do this? Well, when you've got one tool and one connection, it's actually pretty easy. You take that one tool, you plug it into a span port on your Cisco switch. Okay, not bad. If your network's simple and you only got one tool. Maybe you got 3 or 4 data centers. Maybe you got 10 inbound internet points, right? Then all of a sudden you got to plug that tool into 10 points or 4 points to make sure that you're capturing all the traffic from the network you're looking for. Okay, that's great. You've still got one tool. Then for a different application or a different need for your business, maybe you're plugging in a different tool. Maybe you need to monitor the performance of an application over here, but then you needed to actually monitor security from another tool. Then, great, now I've got 2 tools and I'm trying to plug those into 3 places in the network or 4 places in the network. It doesn't take a rocket scientist to see this isn't going to scale well, right? Yeah, there's only really 2 ways to plug into a network, right? To actually monitor traffic. One is by an extra port on a switch, like a Cisco span port. The other way is to put in a physical fiber tap and peel the traffic off. Right? Really, those are the only 2 ways to do it. Both of those resources are strictly limited in most network infrastructures. There's a limited number of span ports. Even if there were more, it's going to affect network performance. There's a limited number of ways you can actually physically tap into a network without disturbing the traffic, without messing up the traffic, without confusing the traffic so much. So you need a better way to scale the network connectivity to the tool connectivity to bring full visibility you want from your network. Okay? What are the visibility needs? There's 5 critical needs when we're looking at visibility into the applications on my network. I need end-to-end visibility. That means loosely, I need to make sure I'm seeing all of the traffic anywhere in my network that I want to be looking at. So if you're only plugging in one place in the network or this place in the network, or only plugging in a data center distribution switch, you're quite often going to miss some of the traffic. And if you need to capture all the traffic for any particular reason for a particular application, you're going to miss some. Scalability. Fundamentally, like any networking problem, you need to make the solution scalable. Scalable means I want to make it easy to scale my performance monitoring or my application monitoring. I don't want to be adding span ports. I don't want to be adding taps. I don't want to get out of control. It becomes a management problem. Third point, becomes a management problem. If you don't scale it properly, you can't manage it properly. That's a tried and true tested thing in networking ever since. Control, view exactly the information you need. One of the interesting things about networks these days is they're carrying more information than you probably want to know about. Okay? We've gone from gig to 10 gig E to 40 gig E to 100 gig E switching environments in big data centers. I don't think anybody really wants to look at 100 gig of traffic of anything these days, right? There's an organization in the US government that maybe does, but the rest of us don't, okay? So you need to control the traffic you're looking at. If you're only actually concerned for compliance and security risk mitigation for a particular type of traffic, that's all you really want to look at. If you don't want to look at everybody's Facebook surfing, don't look at it. If you want to look at the transaction response times on your CRM, just look at that. So that's what control means. Okay? Reduce costs. If you don't do these other things, you're going to have ballooning costs to scale the tools on your network. You want to reduce the amount of traffic going into your tools, and you want to reduce the number of tools, the actual capacity you're spending on the tools. Okay? So let me just draw you a quick diagram, the normal use case of how this might look. I've made this simple. I've just put 3 tools up on the network. I put, say, 3 or 4 places I might be trying to capture traffic on the network. So up on the top, I've got 3 tools. I've got a Gigastore, multi-port collector, got an application performance monitoring tool, all trying to collect traffic for various reasons of just monitoring it. One for security, one for later analysis, okay? And I've just drawn a bit of a messy diagram, and I've said, okay, I've got to take some of the traffic off a span port switch in this data center. Maybe I've got another span port switch in another data center. Maybe I've got a network tap, which is just a physical splitter of traffic in another part of the network. As you can see, that's a 3x3 problem. Each tool now needs 3 connections. I actually need to put 3 connections in each of these span ports or each of these 3 network taps in. That's not a linear problem. In any network engineering or application engineering exercise, we want to try and scale things linearly, control the costs in a linear fashion. So what's the solution to this? Enter something called the network packet broker. Probably for a lot of you a new term, right? Best way to explain a network packet broker is this. Anybody tell me what this thing is? Come on. What is it? It's a power bar, right? Let's see. You plug this in the wall and you've got 4 plugs, right? Why do we buy power bars? Get more plugs. There you go, right? So this is an NPB. It's a network power bar, right? What we're talking about here is the equivalent in the networking space, right? It's called a network packet broker, okay? Same acronym. I just made up the one on the network power bar for fun, right? But enter the network packet broker. It does a similar function in the networking space that a power bar does for when you run out of ports in the network. It's not the only thing it does. It's one of about 3 things it does, but one of the key things it does is it actually adds ports to your network for the tools and the scalability of your tools. That's the first thing it does. So instead of putting 3 ports for my 3 tools on the span port at the left, instead of putting 3 span ports on the switch at the right, which I can't do. You can only actually put 1 span port in, okay? Instead of putting 3 taps in, I'm only putting one tap there, one span port over here, one span port over here, to capture in aggregate all the traffic from the network, feeding it to the device, the blue device in the middle, which is an Ixia piece of hardware called a network packet broker. Then what this does is it actually captures all that traffic, and then the second most important function it does is it filters the traffic based on what those individual discrete tools want on the top of the chart. So it says, hey, the intrusion detection appliance only wants certain traffic, so we're going to filter that traffic out and send it to that tool. The application performance monitoring tool on the top left only wants to look at certain application types or certain traffic from a particular VLAN. So I'm only going to send that traffic to that tool. So it filters the traffic. That's the second most important function. First function provides more plugs in the network, scales that. Second function critically is provides filtering of the traffic to the different tools, different filters for different tools. Okay. That becomes very important because that's the function that says on my application performance monitoring tool or my intrusion detection appliance, all of a sudden, maybe I only need 10 gigs of capacity or 10 megs of capacity or 100 megs of capacity. I don't need the full capacity at that tool coming out of the bottom of the network. So it reduces the requirement on the tool capacity as well and scales that. Third most critical function it does is it does something called a packet deduplication. Okay? So first of all, it's collecting all the packets. But then if for redundancy reasons, resiliency reasons, spanning tree reasons, all sorts of reasons, you have the packets going across multiple links of the network and you're picking it up more than once, it'll actually take out the duplicates. So it's making sure you get all your traffic. It's making sure you don't get any duplicated traffic. And then it's just sending it to the tool. So that's the basic use case. Where I think this actually gets more interesting is in the automation and the API interconnect to this. So moving on to the next use case. CA Spectrum automated incident remediation. This is where this tool, this appliance, and this capability can actually automate functions in the tools. Okay? So going back, here's what we affectionately call the network packet broker sitting in the middle. It's running, doing all of these things. Here, now let's bring in the CA Spectrum product on the side, right? It's actually managing, drilling down, giving visibility into what's going on in the network. Okay. Now, let me run a normal traffic scenario here. Here you have the network packet broker just normally sending, as I've described previously, the traffic to all the tools. Things are running normally. You're at the coffee shop. You're having beers. Everything's running tickety-boo, just perfect on all your applications and network, just like everybody's network. Okay, that was supposed to be funny, isn't that right? So, it comes over there. Now, one thing we've got is a security probe. It's detecting that something abnormal is going on over here on the left side. It says something's not right over here. By whatever rule I've programmed or whatever I'm just normally scanning for and looking for, it says that's not right. Okay, sends up an alert. Okay, then what happens? The alert goes up the spectrum, right? The spectrum, through an API call to the network packet broker, goes down through an automated API call and says, hey, now I want to select a particular type of traffic and send it off to the data recorder. I've detected something funny is going on. Now I have to go take some action and start tracking that funny thing. So then the packets go over there, goes up to the data recorder. For as long as that incident's going on, that is actually recording the incident. So what the beauty of this is, you're out at the coffee shop, you're having beer with your friends, whatever. Your security probe picks up the anomaly, configures the device to go capture packets from that part of the network, and then splits it off and puts it over there. Issue proactively troubleshooted and resolved before it becomes a problem, or at least captured so you can go back and look at the packet stream and see what's actually happening. How does this happen? Here's just a typical network diagram, what's going on. You have your typical mix of Cisco switches, distribution switches and data centers, span ports, typical taps going in, no traffic being transmitted, okay? The packet broker sitting in the middle, waiting, not doing anything for that traffic, okay? Alarm goes off, right? Can actually pull down, oops, and actually say capture packets from this system on the spectrum. What that automated command does is that's the command within the spectrum system that actually makes an API call to the network packet broker and says, capture this specific type of traffic because I want to look at it. Okay? So this is not logging into the system, not saying reconfiguring the packet broker, not doing a lot of manual intervention, not knowing how to do it, but actually just pulling down a drop-down menu saying I want to have a closer look. So we find this very, very powerful. Okay. Here is just a little bit of, we are a box vendor, so here comes the product pitch. Here comes just a little bit of information on the product, but honestly only one slide on the product of things. These basically are actual mostly devices which go in critical parts of your network. So it ranges from the small to the advanced to the super high performance devices. And they're loosely called network packet brokers. We call them NTO devices. That's the naming terminology. And, I think the speeds and feeds are relatively obvious to networking guys, right? Here's a small enterprise one. You can have 4 by 10 gigs or 20 by, 1 gig feeds, right? And these are things that give you network feeds of the packets out of your network and then distribute up to the tools. Okay, ranging all the way up to the high performance thing where you can get up to 100 gig feeds, or you can get 40 gig feeds and 10 gig feeds. All right? Comes in, the enterprise models and the carrier models. The carrier models obviously just being sort of, homologated for telco regulations and such things like that. Now, does this capture everything in your network? I'll presuppose the answer, probably no. Does this capture everything in your physical network? Probably yes. Does it capture everything in your virtual network? So, as a lot of companies have moved into virtualization of the servers, right? Virtual server instances, virtual compute power, virtualization. What this has brought along with it is a virtualized security problem, a virtualized networking problem, a virtualized this, that, and the other set of problems. No different here. This solution, as I've described so far, actually captures at the physical layer all of the traffic that you need to capture for your tools. But there will come a day, if it isn't already there, that you also need to capture this traffic in the virtual world. Okay? And we've also come to that party. Okay? So this is, on the right side, a rather standard type of virtualization of the compute down in the corner here, with your physical server, your hypervisor sitting there, your virtual switch, your kernel module, and your virtual machines running the host OS and the host applications. So what we do here is we bring in a single solution that scales to your virtual world and your physical world. So we don't just provide that network packet broking intercepting capability in the physical switching world. We also provide it as a virtual tap inside the kernel module, okay, of your virtual infrastructure. And most significantly and most importantly, provide the ability to connect that back out into the physical world, connect it back out into that packet broker world I've explained, and then bring with it all the ability to then direct particular types of traffic to particular types of tools. Right? This becomes particularly critical in the data center. And the reason it becomes particularly critical in the data center is because in the data center you can capture most of your, what they call your north-south traffic coming in. It means it's coming into the data center, it's going out of the data center. And you can generally capture that through physical networking infrastructure and physical network packet brokers and physical taps and physical span ports on switches. But increasingly, especially in financial services environments, especially in separated process transaction models and stuff across servers, you have traffic going what they call east-west in the compute farm. and going through the purely virtual networking side of it inside the virtual compute environment. So from a compliance risk perspective, particularly in financials and other regulated industries, you have to make sure you don't have any blind spots on the virtual side as opposed to the physical side, including the physical side, when you're trying to capture traffic. So we actually provide the virtual tapping solution inside the virtualized side of the infrastructure to connect into the physical infrastructure, which I just talked about. So that allows you, from the physical side and the virtual side, to scale your network infrastructure, not invest in extra span ports, not invest in extra physical span ports, extra switching infrastructure, extra unnecessary taps in the network. You just put them where you need to put them. On the virtual side, it doesn't actually impact the performance because it's sitting at the kernel level, fundamentally as a driver, really. It's not even sitting at the switching level. And allows you to connect both the physical world. Global manageability. So the management tools that come with this allows you to manage the physical kind of network taps, the physical network packet brokers, and the virtual tapping to bring the capabilities into the network. All right? That's all I had to say today, and I think I'm just about on time there. I have a 1-minute card there, so.
Just before you leave, Brendan, I just want to say I think I loved your analogy with the power board. And if you were talking to anyone non-IT illiterate, I think the only risk is they'll think you work at Bunnings. But it's a fantastic, I love simple analogies to explain technology, and I thought that's one of the best out there.
Okay.
So if there's no further questions,
I'll leave that with you.
Brendan, thank you very much for your time.